Okay, sorry, wait, give me a second. Okay, now all out. Okay, Sharon, good evening. All good evening. Uh, Today we have few new students. Warmly welcome to our 2026 class. I think you are actual. The year is 2027, but no problem. You can cover if you want to do your exam in 2026. No problem. We can cover. We have time because you have a chance now. You have a chance now because now, from today you have full 1 year and another 4 to 5 months to the exam. Then no issue. You can cover the today. I'm very sorry. Today I can't do subject introduction or whatever background introduction. Today I can't do. We can discuss all tomorrow. We can discuss all tomorrow. We have tomorrow. We have enough time to discuss. Today I have to cover lesson because we are working on a schedule. Always, every class we are working on a schedule. Therefore, I can't get time for that. Your every question, every your problem, you can ask tomorrow class. Tomorrow, our first class for 2027 students. Okay. Okay. Okay, I will explain a little bit only what are the lessons we covered up to now. In our lesson, this is our seventh lesson. This is our not it is seven. This is our then you came now. Okay, Amina is here. Amina is not there. Yeah, she will join. Okay. Okay. When in our class up to now we have covered 6 lessons. The first one we have covered. This is measurement. That's a physics lesson. Measurements and measuring instruments. It is a physics lesson. The second one is the forces and its behaviors. It's also a physics lesson. The third one is the biomolecule we have done. Biomolecule is a biology lesson. We have only 2 biology lessons, biomolecules and cell structure. The biomolecule lesson we have covered. We only have cell structure. Fourth one. The fourth one, the trigonometry and area and volume. First, area and volume we discussed. Area and volume, that's a very simple lesson. Area and volume. This is a maths lesson. We have 5 maths lessons. The fifth one is trigonometry. Trigonometry, that's also a maths lesson. From these 5 maths lessons, 2 lessons are we completed. We have completed up to now two lessons, two mathematics lessons. We have all 5 mathematics lessons. Okay, final one we have discussed the rotational and circular motion. Rotational and circular motion. Rotational and circular motion we have completed up to now. Okay, they are the lessons we have completed up to now. Okay, then how many lessons we have? How many more lessons we have? How many lessons we have more? We have altogether the 25 lessons we have. 25 lessons. From this 25, we have 5 parts, 5 main area we discussed in our syllabus. The first area is the physics. I'll briefly explain the physics. The second one is chemistry. The third one is maths. The fourth one is biology. Fifth one is ICT. The how many physics lesson? We have 5 maths lessons, 5 ICT lessons, 2 biology lessons, and 6 chemistry lesson and 7 physics lessons. Okay, now you can see what are the lessons we have to cover, and what are the lessons we have covered up to now. Okay, they are the lessons we have covered up to now. Today we are going to start our 7th lesson. It is the work, energy, and power. 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 Okay, that's a basic introduction. I just want to give you the full discussion we can do if you don't have idea about our syllabus or our subject, anything. What is a stream also? The stream also you should have some knowledge. You should have some knowledge about technology stream. Tomorrow we can discuss. If you don't have enough knowledge, you can come tomorrow discussion. You can join with that. Okay. Okay, normally every lesson except maths lesson, every lesson we have a printed tute. Printed tute mean PDF or printed tute you can get. But today lesson we have to. Today lesson is actually very small lesson. When we consider about the force in our syllabus, the forces, the biomolecule, the cell structure, the fluid mechanism, they are very long lessons. Their content is very bulk. Therefore, we are not going to discuss this lesson as written note. I am not given written note because that take much time, because we have very limited time to cover all these syllabus. Our target is cover all the syllabus before 6 months to the exam for your batch, for 2026 batch. That's our target. I think we can, according to our schedule, we can go to this target very easily if you because we always going according to a schedule. Okay. This month our target is complete this work, energy, and power lesson. Not only theory, we discussed after the lesson, we discussed the all tutorial session, including all types of questions of this lesson. Previous lesson also, this 6 lesson also we have covered in same way. Okay, write down the topic. Today topic, the work, energy, and power. This is a physics lesson. This is a physics lesson. Then with today lesson, how many lessons we completed in physics part? One, two. This is our third physics lesson. Third physics lesson. Sorry. The rotational motion also physics. Fourth physics lesson. That's also physics lesson. The fourth physics lesson. Okay, don't need to write down like this. Just only write down the work, energy, and power. The work, energy, and power. The work, energy, and power. Okay, if you have any problem, any question, ask tomorrow. Okay, write down, take your book and write down the topic, the work, energy, and power. The work, energy, and power. Same as rotational motion lesson, our previous lesson was rotational motion. This lesson also very small lesson, but it has lot of equation. Lot of equation. That's the nature of the physics lessons. Therefore, this lesson also I decide to give you written note. It will, I think, then you can prepare your note in your way. Then you can, after the class, you can easily understand your written note before I given a printed note. I think better to these short lessons given as written note. Therefore, this lesson you have to write a note. For other lessons like our chemistry part, every lesson you have a printed tube. Okay. Okay. In this lesson, you can see, you can identify in this lesson name three words. Three words you can identify: the work, the energy, and power. You can identify three words, no? Three words. Actually, work, energy, and power. Actually, within this whole lesson, we discussed only this concept. That's the base of the lesson. We whole the every concept we going to deep level. We discussion about in O level time. You know the some few concept of what is the work, what is the energy, what is the power. You already know. But in this lesson, we are going to discuss advanced way in depth discussion about this work, energy, and power. Okay, write down the topic, main topic, the work, energy, and power, and write down the subtopic. First subtopic, the first subtopic, work, 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 work. Okay, what do you mind about the work? What do you know? What according to your O level or previous lessons knowledge? What is the meaning of this work? Work in Sinhala that we called as karya. Karya කියලා නේද? කාර්යයක් කියලා කියන්නේ. Don't need Sinhala word, that is work. Work. Okay, what is the meaning of work? How we define this? The work. The work means, think this is a road or whatever surface, ground level or whatever surface. Okay, think this is a vehicle or any object. Think this is a vehicle or any object. It's a vehicle or any object. This is a surface. On the surface there is an object. Okay, on this object, when we apply some external force on this object, what happened? This object start to motion, start to move. The object start to move in force direction, start to move in external force direction. Now, external force direction. Now think, after some time, it come to this, the same object come to this point, come to this point. Okay, now you can see this object has some, the object has some displacement. The displacement we called as S. You know that. The symbol is S. The displacement. The displacement. The displacement means S or D. S or D. Displacement S or D. Both symbols we can use. We can use D. It's commonly we use D. Okay, you can see this is an object on any surface. Object on any surface. When we provide external force, it is moving. It is moving in force direction. Force direction. Then after some time, it has some displacement. After some time, it has some displacement. Displacement. That means from this point to this point, it's moving. Simple. Okay, when apply some force, on any object, the object is displaced. The object is displaced. In this case, the energy transformation for this process, that we called as the work. How we define now force? The force, you need to carefully remember. You can't now, in your word, you can't, in A level, you can't write equation or definitions in your word. Definitions you can't write in your word. It has some keywords. You need, in your O level time, you know the work unit is joule. No? The joule always the joules always we use for energy measurement. Normally we measure energy by the joules. Then what is the meaning of work for this process? That means when any object given some external force and this object when displaced, the energy transformation for this process that we called as the work. That means on any surface, if there are any object, when given some external force with to become a displacement, the energy transformation that we called as the work. Okay, then how we get the, I will give you definition. How we get the work? What is the equation? We have equation for work. We have equation for work. The work equal right here. The work equal. Is there any disturbance in me because my battery is not sure? My battery is not sure. Okay, still no problem. Let me know if there are any problem. Okay, the work. What is the equation? The work equal external force multiplied by the displacement into force direction. That very important. The displacement into force direction. The displacement into force direction. In O level time, you know only the work equal force into displacement. But now additional part is coming. What is the meaning of The work now, the work means the multiplication between the product between force and displacement into force direction. The displacement into force direction. That is very important in your A-level syllabus because in this case, the force can be act on different directions. I will explain now. The basic equation is the work equal the force, that means external force multiplied by the displacement into force direction. Displacement into force direction. Okay, the short term, the work equal the F, the external force is F into D. That is the short form W equal FD. W equal FD is the short form for work, the short form equation for work. Okay, what is the unit for work? Oh, sorry. Can you hear me? Ah, yeah, you can hear me. What is it? Work. What is the unit for work? What is the unit? I told now. The unit of work is joules. Joules. Wait, give me a second. Okay, now okay. Okay. Okay, the work mean the force into force multiplied by the displacement into force direction. Displacement into force direction. That means the W equal FD. What is the unit of work? The unit of work. Unit of work. What is that? The unit of work is joule. Joules. Joules. The joules. Okay, I will explain what is the meaning of joule later. Just understand the work is what? The work, how we define the energy transformation for the energy transformation of any object to more, the energy transformation of any object to displacement to displace by an external force. That's the meaning. The energy transformation of any object to displace on any surface by an external force. That's the meaning. Energy transformation, always this word is compulsory. Because without energy transformation, you can't define the work. Why? The work unit is joule. The joule, normally energy measured by joules. Remember like this. We discuss in energy part, you can understand. Normally, every energy type we measure by joule. Therefore, the work also should have some relationship between the work also should have some relationship with energy. The work mean the energy transformation of any object to displaced on any surface by external force. Okay, send me this small part is understood. Very simple part I explained on this lesson. Understood? I will give you definition, every equation I will give you now. The basic thing, are you good? Send me all, otherwise I don't know you understood or not. You can chat yes or no. You can send me. Only 5 reply I have, but others not understood. Okay, write down. Write down the first subtopic is work. Write down work. Work. Don't write it is do. You will like only work. Then write down. Write down. The transformation of energy. The transformation of energy. The transformation of energy the transformation of energy to displace any object, the transformation of energy to displace any object, displace any object on any surface, on any surface, on any surface by an external force, by an external force. The transformation of energy to displace any object, to displace any object by an external force called as the work, called as the work, called as the work. Okay, I will say again, the transformation of energy, the transformation of energy, the transformation of energy to any object displaced, to any object displaced, to any object displaced by an external force, by an external force called as the work, called as the work, called as the work. Second point, the second point, the product of an external force, the product of an external force, the product of an external force acting on any object, acting on any object, and the displacement of the object, the displacement of the object into external force direction, into external force direction, into external force direction can obtain the work value, can obtain the work value, can obtain the work value. Okay, draw this and write down the work equal force multiplied by the displacement into force direction. The W equal F into D. The unit of the work is joule. Write down now. Can you repeat the last point, me? Okay. The last point, yeah. The product of an external force and
the product of an external force acting on any object and the displacement of the object into force direction. The displacement of the object into force direction can obtain the work value. The same thing I explained, okay, in second point, the same thing I explained. The force, the product mean multiplication, the force into displacement into a force direction that we called as the work. The work equal the force into displacement into the force direction. The unit of work is joule. Okay, then what is the definition? The energy transformation of any object to displaced on any surface by an external force that we called as the work. These definitions you need to remember with keywords. Keywords are very much important in your A-level answer. Okay, keywords are very much important. Okay. Okay, are you finished? Can I erase? Are you finished? Okay. Okay, we'll do some first question. Question number 1. Example number 1. Okay, draw this. Example number 1. Example number 1. Draw this. Example number 1. Okay, write down below. 5 kilogram object. 5 kilogram object. 5 kilogram object. Start to move. M-O-V-E. Start to move. Because of 50 Newton external force. Start to move because of 50 Newton external force. Start to move because of 50 Newton external force. and it displaced, and it's displaced, and it's displaced, it's displaced 50 centimeter, 50 centimeter, as given above, as given above. Calculate the work, calculate the work, calculate the work done by the object. Write down like this: calculate the work done by the object. Calculate the work done by the object. Okay, get the value. Is that 50 Newton? Yes, yes. The board is not clear. The board is clear. Amavi? Clear neither. Oh. Okay. What is the answer? Send me answers. Send me answers. Yes, Shohit. Correct. Okay, others, what are the answers? No, no. What is the name? I'm not familiar. Dunil. Euro. Yeah, Shuhit Amavi, correct. Okay, what is the equation? The equation is the work equal the force multiplied by the displacement. DOS. Okay, DOS, no problem. Okay, the force is 50 Newton. The force is 50 Newton. The multiply by the distance. Distance is, what is the unit? Distance is now centimeter. The centimeter can be substitute? No, the centimeter is not the standard unit for distance or displacement. The standard unit for displacement is meter. Therefore, 50 meter, 50 centimeter, we need to convert into meter. The 50 centimeter mean, it is half meter. then you can substitute. That means 5 over 10 means 0.5. The 0.5 mean actually half to 1 over 2. Then the value you can say that 50 over 2, it is 25 joules. The 25 joules. 25 joules. 25 joules. 25 joules is the answer. $25 joules. Are you good? All understood? All understood? Dunila, understood? Dunila, understood? Or not? Very good. Okay, more into second question. Second question. Is there any disturb? Send me with board clear or my sound. Is there any disturbs? Send me message, because nowadays heavy rain here. Heavy rain. I think no problem. No problem to our work. Okay. Second question. Second question. Second question. Okay. Draw this. Draw this. Draw this. Draw this. Draw this. Okay, write down below. Okay, Rehlan. Okay, Rehlan, we only discussed what is the meaning of the work. Our topic is work, energy, and power. Only we discuss what is the meaning of work. You can complete that. The only 10 minutes, 15 minutes we did. You can complete that watching our recording. Okay. Write down after drawing that. After draw this, write down below. Write down 10 kilogram, 10 kilogram object, 10 kilogram object, 10 kilogram object on a rough surface. 10 kilogram object on a rough surface. 10 kilogram object on a rough surface given in above figure. 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 If this object displaced, if this object displaced 5 meter, if this object displaced 5 meter, 5 meter, by 5 meter by given 5 meter by given 10 Newton angle, 10 Newton angular force, 10 Newton angular force with 30 degree from horizontal level. With 30 degree from horizontal level. Okay, sorry, I forgot. Correct that. 10 kilogram object on a rough surface is given in the above figure. This object displaced 5 meter by given 10 Newton force, by given 10 Newton angular force, by given 10 Newton angular force 30 degree from the horizontal axis. 30 degree from the horizontal axis. Calculate the work done by the object. 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 Okay, calculate. The meaning is, this is the story. This is the thing. It is rotate. It is more. It is displaced. Now 5 meter. 5 meter. This object mass is given. It is 10 kilogram. That not required. 10 kilogram. Now it is moving. Because of this 10 Newton force. 10 Newton force is the external force. It is 30 degree from the horizontal axis. This is the horizontal axis. This is horizontal, not vertical. Horizontal axis. It is 30 degree from the horizontal axis. They ask, what is the work done by the object when, because of this 10 Newton force, when rotate, when more 5 meter displacement, when more 5 meter displacement. Okay, find that. Find that. This same object, okay, 10 kilogram, same object, because of this 10 Newton angle force, it's moving from this point to this point. The displacement is 5 meter. The displacement is 5 meter. You just want to get the work done by the object. The work done by the object. Okay, other answers? Only 2 answers I have. Sharon, Ro. Sharon, you has mistake. Okay, we'll do it. We'll do it. Now, what is the equation? You just need to get the equation first. The equation is the work equal the force multiplied by the displacement into force direction. Displacement into force direction. Okay, carefully understand what is the equation for work. The external force multiplied by the displacement into force direction. In this previous question, the force direction is that, the displacement direction also same. But what happened now? Now the force direction is this. It is angle direction. It's but displaced into this horizontal direction. Displaced into horizontal direction. The force is applied. The external force is 30-degree angle from the 30-degree inclination from the horizontal axis. 30-degree horizontal inclination from the horizontal axis. Therefore, the force, external force into displacement equation, we can't use for this one. We can't use for this one. Now what we can do? What we can do? We can the work. First of all, we have to prepare this force and displacement into same direction. Force and displacement we can prepare as same direction, like this. 10 Newton we can resolute. I think force resolution you already know. The force resolution. We can resolute this force, this 10 Newton force, we can resolute into this horizontal direction. I think the force resolution mean, you know, the force resolution mean one force we divide into 2 components into perpendicular directions. Think it is 10 Newton force. If it is 30-degree, I can say this component is 10 sine 30. If you can't understand, don't think, it is force lesson. 10 sine 30. 10 sine 30. 10 sine 30. This one is 10 cos 30. Always 10 cos 30. 10 mean this given angle, sine or cos come in according to the this angle. This angle direction is cos, opposite direction is sine. I think you already know that. Okay, now we can resolute this 10 force into this direction. What is our target? Our target is force and the displacement take into same direction, because the work equal for external force into the displacement into force direction. Therefore, we can't change the displacement direction, but we have a method to this force method. The force direction we can change into, we can resolute into horizontal direction. Now, the 10 Newton, we can resolve it into this direction, then angle direction. Therefore, it is 10 cos 30, because the angle is 30, cos because of angle direction, into the displacement is 5 meter, no problem, it is meter, the standard unit. Now, 10 cos 30 value you have to find. 10 cos 30. 10 cos 30 you can get the calculator, or 10 cos 30 you already know 10. The 10 is a constant. Cos 30 means root 3 over 2, no? Root 3 over 2. Then 2 to 2 cancel, 5 into 5. 5 into 5. Then 5 into 5 come in 25. Root 3. 25 root 3 joule. 25 root 3 joules. 25 root 3 joules. 25 root 3 joules. If you can't see, I will write here 25 root 3 joules. The final answer, decimal value also you can get. Amma, have you got 300 value? Have you got 300 value? Multiplied by 90. That's wrong. That's wrong. You have to multiply by 10. Okay, complete that. This is the method that this method we called as force resolution. Force resolution, that's a force lesson part. Force resolution. Okay, understood? Yeah, if you don't know force resolution, you can't understand. The force resolution mean one force we divide into two components. That mean this 10 Newton we resolve it into, now it is the angle is this direction. Now it is angle is this direction, 30 here. This is 30. Then that it's come 10 cos 30. 10 cos 30 because angle direction. The opposite direction from the angle, it is 10 sin 30. 10 sin 30, I think you got now. 10 sin 30. 10 sin 30. Amavi, do you have any lag of our video? Lag එකක් තියනවාද? I think all are okay, or is there any problem with our video quality? No problem. Good. Okay. Next question. Next question. Next question. Question number 3. Example number 3. Example number 3. Example number 3. Ground level. Draw this ground level, and this is a stage. Stage. The height is 2 meters. The height between ground level and stage, it is 2 meters. Okay. Okay, write down. First draw this and write down. First draw this. Write down like this. Write down. Kilogram object at ground level. 2 kilogram object at ground level. 2 kilogram object at ground level. 2 kilogram object at ground level. Lifting up to a lifting okay, lifting up to 2 meter height, 2 meter height stage, up to 2 meter height stage, up to 2 meter height stage, up to 2 meter height stage by 100 Newton external force, by 100 Newton external force, by 100 Newton external force, 100 Newton external force with 60-degree angle, with 60-degree angle, with 60-degree angle from vertical level, given in the figure. Calculate the work done by the object. 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 Okay, now you can do. Calculate the work done by the object. Okay, you need to calculate the work done by the object. Work done by the object. Okay, how we get? How we get it? How we get? Very simple. What you want to do? We need to get the equation, basic equation. The work equal F into D. The work equal F into D. Then the F is given. F is given, but that's not the displacement direction. The F is not the displacement direction. That therefore, what you need to do? What you need to do? You have to resolve that into displaced direction. Displaced direction. This 100 we have to resolve it. Now resolve it into vertical way, because the displace into vertical way. Displace into vertical way. From this level to this level, the vertical height is 2 meters. That's given. That's given. Therefore, we need to get the displacement. We need to get the force into displacement direction. We need to get the force into displacement direction. Now we can, this 100 Newton, we can resolve it into vertical direction. What is the method? 100 cos or sine. Cos or sine. Cos, because angle direction. Cos 60. 100 cos 60 into displacement. Displacement is 2 meter. Displacement is 2 meter. 2. Because of standard unit, we can say it is 2. If it is not a standard unit, we need to first convert into a standard unit and substitute. Okay. Then 100 cos 60. 100 cos 60, you can get the table. Cos 60 equal half. Cos 60 equal half multiplied by 2. 2 to 2 cancel out. 100 joule is the answer. 100 joule is the answer. 100 joule is the answer. Okay, send me, is it okay now? Are you understood, or any problem you can ask now? If there any problem, you can ask now. Others, quickly send me. Is it understood or not? If there any problem, you can ask. I will explain anytime. If there any, if you have any problem, you can send me as a chat message. You can send direct message only for me. Okay, others. Who is there? Guyana. Yumindu. Who is Yatish? How about? Understood? Okay. 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 Now write down the topic, the definition of the joule. 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 Joule mean the standard unit. Don't need brackets. The definition of the joule. The definition of the joules. Okay, I told you the work measure, the standard unit is the work measuring. The standard unit is joules. The work measuring. I told the work is the main unit for energy measurement as well. Energy measurement, the work is the main unit. Okay, now we are going to define what is a joule. Actually, what is the joule is a scientist. Actually, joule is not a unit. Joule is a scientist name. Joule is a scientist name as Newton. Normally, force measurement unit is Newton. The Newton mean the Isaac Newton, part of name of Isaac Newton. Samely, this joule also a scientist name of scientist, part of name, not full name. That's a joule. Joule, the scientist. Then what is the meaning of this 1 joule? How we define 1 joule? That's the exam question. Exam question, past paper question. What is define the 1 joule? 1 joule. I want to define 1 joule. 1 joule I want to define. Okay, how I can define 1 joule? That is very simple. If you know the basic equation, you can define. Think I have object on any surface. Okay, I have object on any surface. This is the object. This is the object on this surface or ground level or whatever surface. This is the object. Okay, on this object, I apply 1 Newton external force. 1 Newton external force. Okay, then because of this 1 Newton external force, if this object displaced 1 meter, same object, okay, don't think about the shape, the same object, if this object displays 1 meter, the work done by the object that we called as the 1 joule. What is the thing? What is the story? When 1 Newton force apply, when displays 1 meter distance, 1 meter displacement, the work done by in this case, the work done by the object that we called as the 1 joule. 1 joule. That's how we define. Very easy, no? The equation is work equal the F into D. Then 1 Newton force apply when displaced 1 meter, the work done by the object that we called as 1 joule. 1 joule. Are you got the definition? When displaced 1 meter by given 1 Newton external force, the work done by the object that we called as the 1 joule. Okay, understood? That's very simple thing. Exam in exam question. That's exam question. Normally in this physics part, when essay questions coming, normally first they ask some definitions or some small theory questions first ask. You can refer, if you go to past papers, you can find they just ask few theory questions. After that, from related to that, they come into calculations. They come into calculations, and final few questions are very complex calculation. That's the order of your paper. Your paper. Okay. Okay. Write down. Write down. Write down. Any object when displaced 1 meter displacement, when displaced 1 meter displacement, 1 meter displacement, by adding 1 Newton external force, 1 Newton external force, by adding 1 Newton external force, the work done by the object is called as the 1 Newton. The work done by the object is called as the 1 Newton. When any object displaced 1 meter displacement by adding 1 Newton external force, the work done by the object that we called as the 1 joule. Okay, finish. Okay, then draw this one and write down like this: 1 joule equal 1 Newton. 1 Newton when displaced 1 meter. That is the 1 joule. You can easily get the short answer that shortly you can remember the 1 joule equal 1 Newton 1 Newton external force when this object is displaced 1 meter. In this object, the work done that we called as the 1 joule. Okay, this point is understood. Are you got the point? Don't need to remember everything. You can get the point. You can understand the point and remember like this. Very short methods you can use. Are you understood the short method? Send me, otherwise I don't know. Send me if there are any problem, ask, okay, anytime. Okay. Umindu, are you understood? Okay. Yatish. Yatish. Gayana. Gayana. Oh yes, Gayana. Understood? Okay. Who first answers? Dunila. 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 Understood? Dunila. Okay, if you draw the definition, you can write down. Very good. If you write the definition, you can draw and this one. Then you can easily remember. Don't always remember definition. Always remember, you can use short methods. In physics, there are a lot of short methods you can find to remember every concept. Then 1 joule mean what? Any object by applying 1 Newton external force, when displays 1 meter displacement, that work done by this object that we called as 1 joule. That's the 1 joule. Then you can explain that in exam pass. In your word, you can explain, but the keyword you should mention. That's important. The keyword you should mention. In your word, you can explain, no problem, but keyword should have. I will explain in tutorial part what are the keywords. Okay, finish. Okay, write down the second topic, energy. Today, if we complete some part of energy lesson, energy part, then within next day and next day you have class. No? Yeah, next week you have. Day after next week you New Year break. New Year break. Okay, I'll send you what are the class schedule. Okay, write down our second one, energy. Second topic, energy. I think you got everything in work more than O level. I think you got something. In O level, you know what is the work mean. Work mean force into displacement. But that's not the correct. That's not the full definition of full concept. I think you got in A level in this lesson. I think you got the full concept of the work. Okay, now we are going to discuss in-depth conceptual things in energy. Energy. Okay, what is the meaning of this energy? What do you think? In your word, can you say what is the energy? In your word, what is the energy? Energy. Sohet, what's according to you understand what is the energy? Energy can mean Shakti can. What is the energy? How we can define? Sharon, no? How we define? Remember that the energy mean the work doing ability, the work doing capacity, or work doing capability. That's the energy. The work doing capability. The work doing capability mean think about us. Think about us. If I have more energy, I can do more work. If I have very low energy level, I can only do very few works. Understood? Therefore, the energy mean the work doing capability. Okay, that's the meaning of energy. Okay, what are the types you know energy? What are the energy types you know? Send me. I need a list of energy. I'll take one. First energy type I know, the light energy. Light energies I know. Others I need from you. Second one, kinetic energy. No, others, kinetic energy. Finally, I need to come to kinetic energy. Kinetic energy is not the main energy type. Okay, today we discussed this in depth. We discussed about kinetic and mechanical energy. Okay, except them, except kinetic and potential energy. Send me what are the other energy type, you know? Other energy type. I need the list. Okay, you can send one by one. I need the list. Light energy. Very good. Yeah, solar energy. The solar energy mean it is very good. Sharon. Yeah, lot of answers. Yeah, I missing something. Yeah, lot of answers. Yeah, sound energy. Very good. I take first one by one. Sound energy. Sound energy. Very good. Sound energy. Third one, I take your answers. Oh, lot of answers. I can't find them. I can't find. Okay, I take one by one. Sound energy, thermal energy, very good. Thermal energy, thermal also heat. Okay, heat energy, heat energy, heat energy. Fourth one, we discuss your one. Yeah, heat and sound. Amavi's answer I have written. The electrical energy, very good. Electric energy. Electric energy. The solar energy mean actually, Yatish, the solar energy mean the in this solar mean it take heat energy and produce electric energy. That's not the solar energy mean actually the heat energy. Yatish, understood? The solar energy mean actually heat energy. Therefore, that's not a nuclear energy. Very good. Nuclear energy. Nuclear energy. The nuclear also has a nuclear energy. Nuclear energy. What others? Electrical energy we got. Thermal energy. Yeah, we got. Yeah. Nuclear energy. Motion energy. Motion energy mean, what's the meaning? Motion energy. Motion energy mean kinetic energy. Wind energy. Very good. Yatish. Wind energy. Wind is a energy type. Yeah. Umindu, you come to point. Yeah, there are different types of energy types in the world. That's not only 5. I got only main energy. Magnetic energy. Magnetic energy. 6 is magnetic energy. Yeah, you are other yeah, chemical energy, very good. Chemical energy. Yeah, lot of answers. I can't find. Gravitational energy. Yeah, all are energy types. In more than 1,000 energy type we can find in our world, in our earth. More than 1,000 energy type we can find. The only I got the main energy types. Okay, you are the also correct. Okay, you are sending it, your answers are also correct. I take here magnetic energy. Magnetic energy also important. No? Magnetic energy. Magnetic energy. And chemical energy, very good. Chemical energy also a energy type. You can write. Okay. Okay. They are the energy type. Okay. Now you can find there are different types of many number of energy type in our Earth. Among that, there is special type of energy type. There is special type of like this energy type. There is special type of energy type that we called as mechanical energy. Mechanical energy. Mechanical energy. Mechanical energy. Mechanical energy. This mechanical energy is among this energy type, the mechanical energy is a very important energy type. In this part, we going to further discuss about this mechanical energy part. Mechanical energy, about mechanical energy. The sound, we have specific, the thermal energy, we have a separate lesson that we called as thermal physics or heat. Electric energy, we have a special unit. The magnetic energy, we have a special unit. The nuclear energy also we discuss some part of in biomolecule lesson. Then and heat lesson we discussed nuclear energy. Okay, therefore other energy type we discussed in further about other lessons. In this lesson, we are going to discuss further about we are going to discuss further about mechanical energy. Mechanical energy. Mechanical energy. Okay, up to now, write down the note, then come to the next part. Okay, write down. Write down. The ability of doing work or the ability of doing work or capability of work. The ability of doing work or capability of work called as the energy. Called as the energy. Next point. If any object has more energy level, if any object has more energy level, it can do more work. It can do more work. If any object has more energy level, it can do more work. Third point, there are different types of energy. There are different types of energy. There are different types of energy in our Earth. There are different types of energy in our Earth. As example, write down as example, you can write down there. Light energy, sound energy, thermal energy, electric energy, nuclear energy, magnetic energy. The final one, write as mechanical energy. Final one, write as mechanical energy. Mechanical energy. Okay, write down next point. Next point. Among that, next point, among that, the mechanical energy is among that, the mechanical energy is the mechanical energy is a special type of energy. Among that, the mechanical energy is a special type of energy. Okay, now write down the topic mechanical energy. Now write down the topic mechanical energy. Mechanical energy. Now write down the topic mechanical energy. Subtopic of mechanical energy. Mechanical energy. Under energy, write down mechanical energy. Mechanical energy. Mechanical energy. Okay, what is the meaning of this mechanical energy? Now you already know what is the light energy, sound energy, chemical energy, magnetic energy, other thing you can imagine. You have some idea. But what is the meaning of this mechanical energy? Mechanical. Mechanical. In Sinhala, Yantrika Shakti. Mechanical energy. What is the meaning? The mechanical energy. Remember, the mechanical energy is the energy type which is because of some object moving or because of some object moving or because of some subject, sorry, because of some object is position, according to the position. Okay, you can understand that if you go through this classification. Okay, now the mechanical energy, we can classify it, we can divide into two main types. The mechanical energy is two main types. Understand, remember very well, this part is always coming in exam. Okay, mechanical energy is mainly two types. The first one is the kinetic, sorry, potential energy. Potential energy. Potential energy. Potential energy. The second one is kinetic energy. Kinetic energy. What's the meaning? The mechanical energy is, what is the mechanical energy? Because of some object position or because of some object moving or yeah, because of some object moving or because of some object somewhere position, the object stored energy that we called as mechanical energy. The mechanical energy mainly two types. The mechanical energy mainly two types. The mechanical energy mainly two types, the potential energy and kinetic energy. Potential energy and kinetic energy. Now, potential energy and kinetic energy. Now, this potential energy means the according to some object position, this object stored energy that we called as potential energy because of some object moving, the object stored energy that we called as kinetic energy. Now that the basic meaning, the basic the overall, not overall, the basic idea you have, the potential mean object is position, the kinetic mean the object is moving. Okay, now this potential energy we can divide again into two types. Potential energy I can divide again into two types. This kinetic energy also we can again divide into two types. Okay, the potential energy, we can divide. The first one is gravitational potential energy. Gravitational potential energy, I will take is in short form. Gravitational potential energy is the first one. The second one is elastic potential energy. Elastic potential energy. Elastic potential energy. The kinetic energy also mainly two types. That is, the first one is linear kinetic energy. Linear kinetic energy. The second one is rotational kinetic energy. Rotational kinetic energy. I will take short form kinetic energy. The linear kinetic energy and rotational kinetic energy. Then mechanical energy, basically we divide into finally four parts: the gravitational potential energy, elastic potential energy, linear kinetic energy, and rotational kinetic energy. Okay, now I think Shohet, I think your question was solved now. The kinetic energy and potential energy is not the main energy type. They are kinetic energy and potential energy are the part of subunits of subtypes of mechanical energy. So are you understood? Okay. Okay. Okay, others, I got the point. The mechanical energy mainly two types: potential energy and kinetic energy. The potential energy two types: gravitational potential energy and elastic potential energy. The kinetic energy also two types: linear kinetic energy and rotational kinetic energy. Okay, now we are going in this lesson. Now we are going to discuss one by one what is the gravitational potential energy, what is the elastic potential energy, how we get the equation for gravitational potential energy, how we get the value in a decimal, in a numerical value, how we get the this energy calculation. Now we are going to discuss in depth about this each and every energy types. Okay, write down. Write down. Write down. The energy, first point, the energy stored, the energy stored on any object, the energy stored on any object due to the energy stored on any object due to its position or due to its position or moment, its position or moment, called as the mechanical energy, called as the mechanical energy. Next point, the mechanical energy can be classified, the mechanical energy can be classified, the mechanical energy can be classified into two main energy types. Into two main energy types, the mechanical energy can be classified into two main energy types. First one, potential energy. Second one, kinetic energy. First one, potential energy. Second one, kinetic energy. First one, potential energy. Second one, kinetic energy. Potential energy, kinetic energy. Okay, write down again next point. Next point. Potential and kinetic main energy types. Potential and kinetic main energy types again can be classified into four main energy can be classified into four main sub energy types. Four main sub energy types as below can be classified into four main can be classified into four sub energy types as below. Okay, write down at the top mechanical energy, then classified into two types, potential and kinetic energy. Then potential energy classified into gravitational potential and elastic, and kinetic energy classified linear and rotation. You need to draw that. What happened? Okay. Okay, you have to keep some space and you need to draw this classification. The mechanical energy we divide into two main types, the potential energy and kinetic energy. The potential energy again two types, gravitational potential energy and elastic potential energy. The kinetic energy again two types, linear kinetic energy and rotational kinetic energy. Okay, keep some okay space. I can't imagine what is the space required. You can complete that while watching recording. Oh, sorry, sir. Okay, I finish. Finished. Okay. Now, 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 write down the first subtopic, potential energy. Write down the first subtopic, potential energy. First subtopic, potential energy. Potential energy. First subtopic, potential energy. Potential energy. Write down potential energy as subtopic. Potential energy. Okay, what is the meaning of potential energy now? Now we are going to one by one discuss. Okay, one by one discuss. What is the meaning of potential energy? If I today, if we complete this chart discussion, next day we can go for energy conservation law part. Then next week we can go for calculation practice. Then final day we can do tutorial. Then discuss tutorial and finish the lesson within this month. Okay. Okay, write down the potential energy. Okay, what is the meaning of potential energy? The potential energy means simple. The object stored energy, the object energy, object available energy because of the position of this object. Because of the position of this object due to position. Okay, due to position. That is the potential energy. Potential energy. That's the basic thing, basic definition for potential energy. We'll see it's come to gravitational potential energy and elastic potential energy, how it is changed. Actually, you can imagine. Okay, we'll see. The potential energy. Okay, write down. Under potential energy, write down. The energy stored on the energy stored on an object due to its position or height from the its position or height from a reference point. Height from a reference point due to position or height from a reference point. You can see in future discussion what is the meaning. The potential energy means what? The stored energy due to its position, due to object position or the height from some reference point, height. Okay, now write down subtopic under potential energy, write down A or whatever in your method, A or whatever method, gravitational potential energy, subtopic under potential energy. Subtopic under potential energy, write down gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Gravitational potential energy. Okay, what is the meaning of this gravitational potential energy? Gravitational potential energy. The gravitational potential energy I will draw here. The gravitational potential energy means, think this is an object. Think this is an object. This is the ground level. Okay. This is the ground level. Oh, I will erase that. Yeah, it will erase. I will erase this part because it needs in future. Okay. Gravitational potential energy. Okay, focus into that. The gravitational potential energy mean, the gravitational potential energy, think this is the ground level. Ground level. This is the ground. Think there is a stage or whatever on this stage or whatever surface, some height from this ground level. Height from this ground level. Okay, because of this position or height from the reference point. Reference point means ground level. The gravitational, you can understand, gravitational mean because of the gravity. Because of the gravity, due to position of the object, the stored energy that we called as the gravitational potential energy. Gravitational potential energy, what's the meaning? Due to gravity, with relative to the gravity, if there are any gap, if there are any height from the ground level to object, this object has stored the gravitational potential energy. Are you good? That's the gravitational potential energy. Do I need to explain again? If you want, you can send message, then I will explain again. If you can't, if you couldn't understood, send me at the same time. Otherwise, if you late, it can disturb. Therefore, if you not understood, you can send me quickly. Then I can, before I move into next part, you can let me know. Then it's easy. Okay, write down the energy stored in any, the energy stored in any object, the energy stored on any object, on the energy stored on any object, the energy stored on any object due to its position, change with the position, change with gravitational field. Its position change with gravitational field. Gravitational field. Next point. There are three main factors. Affecting for gravitational potential energy. There are three main factors affecting for gravitational potential energy. Gravitational potential energy. The first factor is Write down first factor, height from the first factor, height from the height from the gravity, height from the gravity that within bracket h, the second factor affect to the gravitational potential energy. The second one, gravitational acceleration. Gravitational acceleration. Within bracket, it is G. Within bracket, it is G. The final factor, mass of the object. Mass of the object. It is simple M. Mass of the object. Third one, mass of the object. Mass. It's not capital M, it is simple M. Simple M is the mass of the object. Simple M. Okay. Okay, now consider about object. I will erase that. You have written. When we consider about any object from some height with the gravity, its position is with some height from the gravity. Think the mass of this object is m. The mass is m. From gravity level, the height is h. The position height is h from the gravity level. Gravity level means ground level. Okay. Then the gravitational acceleration, you know, it is a constant. No, it is 10 ms minus 2. Gravitational acceleration means when we consider about freely moving, when we consider about freely moving any object in our atmosphere, that's moving with gravitational acceleration. You already know the gravitational acceleration value is the G equal, in your O-level time, you know it is 10 ms minus 2. In this case also, in our syllabus also, we use the gravitational acceleration as 10 ms minus 2. 10 ms minus 2, therefore no problem. Then the potential energy, we can get according to these factors affect for gravitational acceleration. We can say the gravitational we can say the potential energy equal gravitational potential energy equal mgh is the equation. mgh, you need to carefully remember. The equation for gravitational acceleration, gravitational potential energy, it is mgh. Gravitational acceleration means that, okay. Gravitational potential energy, it is mgh. Mgh means the mass of the object multiplied by the gravitational acceleration and the height from the gravity level. Are you good? Okay, others, are you understood? Or any problem? You can ask. Okay. First draw this. First draw this. And the G you already know. The draw this and write down gravitational potential energy equal mgh. Mgh you already know. The m mean the mass of the object, g mean gravitational acceleration, h mean height of the object. Height of the object. Height of the object from gravity level. Height of the object from gravity level. Height of the object from gravity level. The gravitational potential energy equal mgh. M mean the mass of the object, g mean what? Gravitational acceleration. The h mean what? The height from the gravity level. Height from the gravity level. If you don't know, you can label. Okay? You can label. Mgh is the equation. Mgh. Mgh. Okay. Okay, what is the unit of this gravitational potential energy unit? What is the unit of gravitational potential energy? Do you know? The unit of gravitational potential energy, what is that? The unit of gravitational potential energy, what do you think? The gravitational potential energy unit, what's that? Gravitational potential energy unit. Do you need to worry? Don't need to worry because every types are energy, no? Then the unit is joule. The unit is joule, same as the work. The work unit also joule. The gravitational acceleration, sorry, gravitational potential energy unit also joule. Because energy type, no? I told the all the energy type, the unit is joule. The sound energy or whatever the energy, light energy, or we measure by heat energy as well. The heat energy in heat lesson we discussed, not we discussed yet. In heat energy measured by joule. The energy, no, all energy type we measure by joule. Okay, now you know what is the 1 joule definition. Also, you now you already know. And what is the meaning of work, and what is the definitions of work, and what are the equations of work, and units, definitions, everything you already know. Okay, write down the next topic, elastic potential energy. We'll do calculations of this part after all these energy types are discussed. Okay, write down the second subtopic, elastic potential energy. 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 Okay, what is the meaning of this elastic? Elastic mean what you know about elastic word? Elastic, what's the mean? The elastic mean I need a rubber tape. Okay, that at that time I don't have. Okay, now you can imagine the elastic mean when we supply any external force, when we given any external force, the shape is changing. That's the elastic mean. The elastic mean, think it is a rubber tape, rubber string or whatever. Think now this is the height or length of this tape in string. If I given any external force, what happened that? The same one, the length, what happened? Increasing. Length is increasing up to this level. Then you can see the length is increasing. Initially this level, after we give external force, it's become this level that we called as E. That actually the elasticity we discussed in the next lesson, our mechanical property lesson. Okay, now I am only given you the definitions and equation only. This E mean actually the increasing length because of this force. That names and that definitions you can learn in the next lesson of our next month lesson. You can learn elasticity and everything about mechanical properties of substance. Mechanical properties of substance we discussed in next lesson. Okay, this elasticity we in depth we discussed in this elasticity in the next lesson. Then you can learn the elasticity. Elastic potential energy mean because of this deformation, object stored energy is the elastic potential energy. Elastic potential energy mean because of when we apply any force on any deforming object, because of this deforming, this object is stored some energy that we called as the elastic potential energy. Elastic potential energy, we have a special equation for elastic potential energy. The elastic potential energy, we have two equations. Half Fe. Half Fe mean the external force given F. The E mean increase in length. The elastic potential energy, we have another equation as well. That is half K E square. This K I can't explain here because that's a long background you should know to understand K. The K is actually a constant. Will again be discussed in this two equation in the next lesson. Therefore, you can only write down. Then we can discuss in the next lesson. Okay, write down. When change the natural shape of any object using an external force, using an external force, using an external force, when change the natural shape of any object using an external force, using an external force, the object stored energy, the object stored energy called as the object stored energy called as the elastic potential energy, elastic potential energy, elastic potential energy. Now, don't you have any problem? I told you the potential energy mean the change the position because of change position. Now, in this elastic potential energy, is there any position change? Yes, position is changing. Why? Think at the initially without any external force, this is the position. What happened to the after we apply external force? The position is changing, the length is increasing, the position is changing. The basic meaning of the potential energy, when change the position of any object, the object stored energy is the potential energy. The gravitational potential energy mean because when due to the gravity level, the object position change, that we called as gravitational potential energy. Due to the elasticity, elasticity means the deforming due to an external force, the position change, stored energy, that we called as elastic potential energy. Okay, up to now understood? Up to now, are you good? Are you good up to now? Dunula, are you good up to now? Okay, good. Very good. Okay. Okay, write down these two, both equation. Elastic potential energy equal half Fe. Half Fe, don't need to label. I will explain in the next lesson. The elastic potential energy equal half Ke squared. Ke squared. Just only write down that enough. You can understand them in the next lesson we again discussed. Okay. Okay, we have another 15 minutes. Try to complete our 9:15. I need to stop today class. Okay, try to complete these energy types. Okay, write down next main topic, kinetic energy, not subtopic. The main topic, kinetic energy. Kinetic energy. Write down. Make your paper, so make your notes very clear. Okay, then after any time after the class, after we discuss any time 2 months or 1 year after, You can quickly go to your notes if you write down the note very clear. Therefore, keep your notes very clear. It will very help for your uh, future studies. Okay. Kinetic energy. Kinetic energy. Kinetic energy. Okay. What is the meaning of kinetic energy? Kinetic energy. Now you already know the kinetic energy means the because of due to any object is moving, this object stored energy. That's the meaning of kinetic energy. Okay, write down. Write down. The energy stored, the energy stored in any object, the energy stored on any object, on any object due to object motion, due to object motion is called as the is called as the is called as the is called as the kinetic energy. Is called as the kinetic energy. Kinetic energy. Called as the kinetic energy. Okay, now write down first subtopic under kinetic energy. First subtopic under kinetic energy. Linear kinetic energy. Linear kinetic energy. First subtopic under kinetic energy, linear kinetic energy. Linear kinetic energy. Linear kinetic energy. Okay, what is the meaning of this linear kinetic energy? Linear kinetic energy means think a vehicle is moving in this case, in this type of motion. Think a vehicle is moving. Vehicle is moving or object is moving with vertical or horizontal way, not rotating. The object is moving with horizontal or vertical way. The object stored energy that we called as the linear kinetic energy. When the object is moving in linear way, actually the simple meaning is not rotating. Without rotating, when any object is moving without rotating, the object stored energy that we called as the linear kinetic energy. Are you got? I got the linear kinetic energy. Okay. Linear kinetic energy. Okay, the linear kinetic energy, we can get the equation for linear kinetic energy. That also, there are two main factors are affecting for linear kinetic energy as well. The first factor is the mass of the object. Mass of the object, that means simple M. The second factor is the moving velocity. Velocity. Moving velocity. The moving velocity is simple V. Then I can say the linear kinetic energy equal half mv squared. This is the equation for linear kinetic energy. Linear kinetic energy equation is half mv squared. Half mv squared. Okay, write down. The energy stored on any object, the energy stored on any object, the energy stored on any object due to its linear motion, due to its linear motion, called as the linear kinetic energy, called as the linear kinetic energy, linear kinetic energy, linear kinetic energy. Next point, there are two main factors. There are two main factors are affected. There are two main factors are affected on linear kinetic energy. On linear kinetic energy. Write down first one, mass of the object. Write down first one, mass of the object. Mass of the object. The second one, velocity of the object. Mass of the object, simple m. Velocity of the object, simple v. Okay, after that, draw this figure m, the m mass moving with v velocity, moving with v velocity. After draw that, you can write the linear kinetic energy equal half mv squared. The linear kinetic energy equal half mv squared. First draw this. So first draw this and write down the equation. Okay, then what is the linear kinetic energy? What is the unit? The linear kinetic energy, what is the unit? That's also joule because it's also energy. That's also unit. Joule. The unit is joule. That's also joule. Okay, write down first one, first topic for today. Sorry, last topic for today. Last topic for today, rotational kinetic energy. 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 Okay, what is the meaning of this rotational kinetic energy? Rotational kinetic energy. We'll see. The rotational kinetic energy mean because of the rotating of any object. The rotating also a motion. The rotation also motion. Think if there are any object need to rotate, it should fix any. In our movement of forces lesson we have discussed, it should fixed anywhere. It should fixed. Then it can rotate. It can rotate. Because of this rotating of any object, the object stored energy that we called as the rotational kinetic energy. Rotational kinetic energy. Same as linear kinetic energy, there are two main factors are affected for rotational kinetic energy as well. The two factors are first one is the moment of inertia. Moment of inertia we discussed. The moment of inertia we discussed in the rotational motion lesson. The moment of inertia. The moment of inertia. The moment of inertia, that means capital I, the moment of inertia. The second one is the angular velocity. Angular velocity. Angular velocity, you already know the angular velocity is omega. We discussed in the rotational motion lesson. Okay, there are two main factors are affecting on any rotational. Think we have a rotational disc like this. This is a rotational disc. This radius is r. This is rotating. This is rotating in this object. Because of rotating, it stores some energy. It stores some energy that we called as the rotational kinetic energy. There are two main factors are affecting moment of inertia that you need to go through the rotational motion to understand the moment of inertia. The next one is angular velocity, that is omega, not w. Omega, that's a Greek letter. The w is like this. It is w. The omega mean like this. Omega. Then we can get the relation. We can get the equation for rotational kinetic energy. Rotational kinetic energy equal half I omega squared. Half I omega squared. Half I omega squared. I omega squared. Okay, that's a today lesson. If you write down this note, that's a today lesson we discussed. I will give you full summary of today lesson after writing the note. Okay, write down. The energy stored on any object, the energy stored on any object, the energy stored on any object due to rotating the object, called as the rotational kinetic energy. Called as the rotational kinetic energy. Called as the rotational kinetic energy. Next point, there are two main factors are affected. There are two main factors are affected. There are two main factors are affected for rotational kinetic energy as well. For rotational kinetic energy as well. Write down first one. Moment of inertia it is capital I. The second one is angular velocity, it is omega. 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 Omega. Angular velocity, it is omega. Okay, now write down the rotational kinetic energy equal half I omega squared. Half I omega squared. Rotational kinetic energy equal half I omega squared. Half I omega squared. Half I omega squared. Half I omega squared. Okay, now you have a work. You have a work. Now the mechanical energy we can divide into two. Potential energy and kinetic energy. And kinetic energy. Potential energy and kinetic energy. This potential energy again two types. Gravitational potential energy. I use short form now. The elastic potential energy. The kinetic energy also mainly two types. Linear kinetic energy and rotational kinetic energy. Linear kinetic energy and rotational kinetic energy. Linear kinetic energy and rotational kinetic energy. Now you can prepare a short note for your understand. The gravitational potential energy, what is the equation? mgh. mgh. Elastic potential energy, what is the equation? We have two equations, no? Half ke squared o, half fe. Half fe. Linear kinetic energy, half mv squared. Half mv squared. The rotational kinetic energy, half I omega squared. I omega squared. Half I omega squared. Okay, that's the today lesson. If you want, you can draw this summary as well. If you want only, that's not required. Only every equation I have given in the note. Every equation I have given in the note. Okay. Okay, how about today lesson? Are you understood all? Any clarification if you want, you can ask now. No problem. You can ask. Now 9:30. Okay, others? Any clarification about any part? No. Good. Okay, now 9:30. I hope to finish the lesson 9:15, but no problem. Okay, now you have work. Before next week, you need to familiar this uh, definitions and equation. Gravitational potential energy definition and equation. Definition and equation. Each one definition, and definition mean don't need full the by heart. The understand only the concept. If you in your mind the concept, if you have that enough. Okay. Mm, okay. If you don't have any question, we can wind up the today class for this week. Okay, no problem. If you want, you can take a screenshot or whatever, or you can write down. Okay, then we meet next day. Tomorrow you have important session for 2027 students. If you don't, if you are new to subject, you can join with that. Then you can get all information about our stream and our subject and our syllabus, every information, and how to need to work and how to select to university, and how you go for higher education and job opportunities. Everything I will discuss tomorrow 6:30 same time, 6:30 to 8:30 only tomorrow. Okay, good night. Okay, good night all.